Hi, how are you guys doing? I hope everything is good. Today, we are going to present something about welding. As we know, there are so many types of welding in manufacturing process. So, we are here to explain to you those are. The first type of welding that we are going to show you is oxy-fuel welding. So, please let me explain to you what oxy-fuel welding is. We have divided the presentation into some topics. As you can see there, I'm going to explain to you first the definition of oxy-fuel welding, then I will move to the flame types, filler metal, equipment, and finally procedures on how to perform oxy-fuel welding. Oxy-fuel gas welding is a general term used to describe any welding process that uses a fuel gas combined with oxygen to produce a flame. The flame is the source of the heat that is used to melt the metal at the joint. The heat is generated in accordance with a pair of chemical reactions. The primary combustion process, which occurs in the inner core of the flame, involves the following reaction. The first reaction there. This reaction dissociates the acetylene into carbon monoxide and hydrogen and produces about 1/3 of the total heat generated in the flame. The secondary combustion process is the second reaction there. This reaction consists of the further burning of both the hydrogen and the carbon monoxide and produces about 2/3 of the total heat. Note that the reaction also produces water vapor. The temperatures developed in the flame can reach 3300 degrees Celsius. Okay, next, the proportion of acetylene and oxygen in the gas mixture is an important factor in oxy-fuel gas welding. At a ratio of 1:1, the flame is considered to be neutral. With a greater oxygen supply, the flame can be harmful, especially for steels, because it oxidizes the metal. For this reason, a flame with excess oxygen is known as an oxidizing flame. If the oxygen is insufficient for full combustion, the flame is known as a reducing or carburizing flame. Okay, so what is filler metal? Filler metals are used to supply additional metal to the weld zone during welding. They are available as filler rods or wire and may be bare or coated with flux. So why do we need filler metal? The purpose of the flux is to retard oxidation of the surfaces of the parts being welded by generating a gaseous shield around the weld zone. The flux also helps to dissolve and remove oxides and other substances from the weld zone, thus contributing to the formation of a stronger joint. The slag developed protects the molten puddle of metal against oxidation as it cools. How to choose filler metal? The first one, determine chemical composition and tensile strength of the best metal. The second one, determine the welding process. And the third one, identify the right welding electrode. The next one, there is equipment oxy-fuel welding. The first one, we need welding torch. The second one, pressure gauge and the regulators. The third one, of course, is safety equipment, such as glasses with shaded lenses, face shields, gloves, and protective clothing. Okay, the last one is process oxy-fuel welding. The first one, reheating of the interface of the two materials that we want to weld. The second one, after the interface begins to melt, the torch is withdrawn. The third one, a force is applied to press the two components together. And the fourth one, we wait until the interface solidifies.
Gas tungsten arc welding, or GTAW, is an electric arc welding process that produces an arc between a non-consumable electrodes and the work to be welded. GTAW is generally considered the most challenging welding method to master. It is more time consuming than other welding methods. Even when practiced with the care of an expert, the improved strength and quality of weld produced with GTAW can offer a practical alternative to simpler welding methods. So, how does the GTAW process work? GTAW, also known as tungsten inert gas welding, is a type of arc welding which produces the weld using a non-consumable tungsten electrode. The size of an electrode to be used is determined by welding current required. Larger electrodes permit higher currents to be used, but smaller diameter electrodes may be used for welding thinner materials or while welding out of position. Inert gases such as argon and helium are used to protect the area being welded from contamination and most, although not all, welding applications will require filler metal. The gases used to protect the tungsten electrode and the molten weld pool from the atmosphere. With GTAW, the welder must maintain a very short arc length while preventing contact between the electrode and the work itself, which requiring a great deal of training, skill, and care. Two hands are usually required with GTAW, as one hand will be operating the welding torch while the other hand feeds the filler metal into the weld being created. Now, what is the application of cast tungsten arc welding? GTAW originally developed for welding aluminum and magnesium, but it also used for joining various combinations of dissimilar metals like brazing and braze welding. Here, the example of application from GTAW. First, the tanks on NASA's Saturn V rocket, which supported the Apollo program. Second, automotive construction and repair, including roll cages, frames, and exhausts. Third, ship fitting. Fourth is petrochemical and pipe application, which requires for its high pressure steam lines. And fifth, metal artwork and ornamental application. And the last is maintenance and repair. So, the next is what is the advantages and disadvantages of using GTAW? For the advantages, GTAW has clean and high quality welds. It welds a wide range of metals such as aluminum, coal, steel, bronze, nickel, brass, copper, and magnesium. No spatter or slag, sparks, or smoke, which helps in making a neat and sounder weld. However, GTAW also has disadvantages, such as it has lower deposition rates. It also requires high level of operator skill, which needs to have a good eye and hand coordination to achieve quality welds. GTAW also has a higher level of UV rays. It is also high-cost welding because of using the inert gas, coolant, and coolant pump.
So here now I will explain about plasma arc welding, or we call it as PAW. So first we go to the definition and working principle of PAW. The definition of plasma arc welding is initiated by an electric arc transferred from a torque body to the workpiece via a high temperature, high velocity plasma jet forced through a constricting nozzle, hence delivering a high concentration of heat to a very small area to melt the weld material and fuse the weld joint. And now we go directly to the working principle of the plasma arc welding. Plasma arc welding is a method wherever a collision is generated with the temperature which is developed from a special setup between a tungsten alloy electrode and a water-cooled nozzle, or that we call it as transfer ARC, or between a tungsten alloy electrode and the job, that we call it as transfer ARC. In this type of winding, there are three types of gas supplies being utilized, namely plasma gas, shielding gas, and back-purge gas. Plasma gas supplies throughout the nozzle turn into ionized. Then the shielding gas supplies throughout the external nozzle and protects the joint from the environment. Then the last is back-purge gas is mainly used when particular materials are being used. And now we go to the next part, which is the equipment used in the plasma arc welding process. So the equipment that we use first is power supply. The power supply used in the PAW is a DC power source, and the suitable voltage for this type of welding is 70 volts or higher. Then the second equipment that we use is current limiting resistor, as well as a high frequency generator. Current limiting resistor is used for arc ignition. And then the next is the plasma torque, includes an electrode as well as water cooling arrangement. These are used to save the nozzle and the electrode's lifespan from dissolving due to the extreme heat generated while welding. And then the next is fixture. The fixture is necessary to avoid atmospheric pollution from the molten metal beneath it. And then the last is the shielding gas, is used for protecting the arc region from atmosphere. Okay, now we go to the next part, that is talking about advantage and disadvantage of the PAW. So we go to the advantage. The first advantage is power consumption is low, and then the second is welding speed is high, so it can simply utilized to join thick and hard workpiece. And the third, penetration rate and strong arc are high. And then the next is it can function at little amperage. The next is the arc arrangement doesn't affect by the distance among tools as well as the workpiece. And then the last is by using this method, the steadier arc can be produced. And what is the disadvantage of this process? So the first disadvantage is the process is noisy. And then the equipment cost is relatively high. And if we want to do this welding, high expertise labor is required. And the radiation is more in this welding. And now we go to the last part, which is the application of plasma arc welding in the industries. So the first application is PAW can be used in industries like aerospace as well as marine. And then PAW is used to join stainless tubes and pipes. And this type of welding is mostly applicable for electronic industries. Then PAW is mainly used to fix tools, mold, and die. And then last, PAW is used to coating otherwise welding on the turbine blade. And that's all about the plasma arc welding.
Now we are moving on to the new topics, which is the SMAW or the shielded metal arc welding. And before we go further to the material, let's go to the introduction first. So basically, what is SMAW? So shielded metal arc welding is a process where the arc is struck between an electrode flux coated metal rod and the workpiece, and both the rod and the surface of the workpiece melt to create a weld. It was firstly invented in Russia at the year of 1888, and it involved a bare metal rod with no flux coating to give a protective gas shield. It also developed in the UK in the year of 1900s when the joule process was invented in Sweden and the quasi-arc method was introduced in the UK. And it is worth noting that unfortunately, the coated electrodes were slow to be adopted because of their high cost. Now let us just jump to the component. As what we can see from the pictures, the left side shows the power source and also the control. For the power source itself, it can be AC or DC, and it connects to two cables. The first cable is the work cable, which connects to the work clamp, and it will clamp the workpiece. And the second cable is the electrode cable, which connects to the electrode holder, and also, of course, it will hold the electrode. In that point, the arc will occur. Now, let's just evaluate the advantages of the SMAW. So, SMAW is very simple, portable, and also inexpensive equipment. It can be used for a wide variety of metals in any welding position, and electrodes are applicable. It's also suitable for outdoor application. But despite of this advantage, we also have the advantages of the SMAW. So this is the disadvantages. The first is the process is discontinuous due to the limited length of the electrodes. And the second is that the weld may contain slug inclusion, and also fumes make difficult the process control. So by seeing the advantage and the disadvantage of the method, now we are going to see the common uses of the welding method. So the SMAW is usually used for pipeline, shipbuilding, construction, farm machinery, and also underwater welding. And this is all the brief explanation about the shielded metal arc welding or the SMAW. Now we are going to move to the other topics.
Hey yo, it's me Tasha, and I'm going to explain about diffusion bonding. Do you guys know what is diffusion bonding? Diffusion bonding or diffusion welding is basically a solid state welding technique used in metalworking. Its function is to joining similar and dissimilar metals. The bonding strength depends on pressure, temperature, time of contact, and the cleanness of the interface. But why? Why it depends on pressure, temperature, time of contact, and the cleanness of the interface? The answer is because first, temperature determines the extent of contact area and the rate of diffusion. Temperature is the most influential variable since it determines the extent of contact area during the stage 1 and the rate of diffusion, which governs void elimination during the second and third stages of welding. Second, pressure produces a large area of contact at the joining temperature. Pressure is necessary only during the first stage of welding in order to produce a large area of contact at the joining temperature. Removal of pressure after this stage does not significantly affect joint formation. However, premature removal of pressure before completion of the first stage is detrimental to the process. Third, rough initial surface finish generally adversely affect the welding. Rough initial surface finish generally affect the welding by impeding the first stage and leaving the large voids that must be eliminated during the later stage of welding. And the last one is the time required to form a joint. It depends upon the other two factors. The time required to form a joint depends upon the temperature and pressure used, and as what have been mentioned before. And it is not an independent variable. It depends on temperature and the pressure used. The next section will be the stage of diffusion bonding mechanism. In the first stage, the formation of the contacting asperities occurs primarily by yielding and by creep deformation mechanism to produce intimate contact over a large fraction of the interfacial. At the end of this stage, the joint is essentially a grain boundary at the areas of contact with voids between these areas. During the second stage, diffusion becomes more important than deformation, and many of the voids disappear as grain boundary diffusion of atoms continues. In the third stage, the remaining voids are eliminated by volume diffusion of atoms to the void surface. Every system and method has its own plus and minus, and after this, I will tell you about the disadvantages and the advantages of diffusion bonding. There are several advantages that we can get from diffusion bonding, and it divided into two aspects, economic and mechanism. For economic, we can get first, simple starting blank form, and it particularly significant for titanium. Second, high material utilization. Third, reduced part count. And fourth, process times, which are intensivity to size, complexity to structural form, or number of components manufactured in one operation. While for the mechanism advantages, we can get first, joint can be produced with properties and microstructure very similar to those of the base metal. This is particularly important for lightweight fabrication. Second, component can be joined with minimum distortion and without subsequent machining or forming. Third, a large number of joints in an assembly can be made simultaneously. Fourth, components with limited access to be joined can be assembled by these processes. And the last one is defects normally associated with fusion welding are not encountered. The last section will be the disadvantages. Basically, the disadvantages for diffusion bonding occurs because of the technical problem. The first one is generally the duration of the thermal cycle is longer than the conventional welding and brazing processes. Second, equipment costs are usually high, and this can limit the size of component that can be produced. Third, the processes are not adaptable to high production application, although a number of assemblies may be processed simultaneously. Fourth, adequate non-destructive inspection technique for quality assurance are not available, particularly those that ensure design properties in the joint. Fifth, suitable filler metals and procedures have not been developed yet for all structural alloys. Sixth, the surface to be joined and the fit up of mating parts generally required greater care in preparation than the conventional hot pressure welding or brazing process. And the last one is the need of simultaneously apply heat and a high compressive force in the restrictive environment of a vacuum or protective atmosphere is a major equipment problem with diffusion weldings.
Brazing. What is brazing? Brazing is a process of joining two pieces of material in which a non-ferrous alloy is introduced in a liquid state or melted, then filled in between the pieces of material and allowed to solidify. The process of brazing in general is, the brazing metal is heated several degrees above its melting point to slightly melt it and be filled between the two materials that will be joined. The illustration is like this. In brazing, there are several types of processes, which are torch brazing, furnace brazing, dip brazing, resistance brazing, and induction brazing. There are some advantages of brazing. First, dissimilar metals and parts having a thin section can be easy. Second, by doing brazing it may avoid the metallurgical damage to the base metal. Also, the strong joint can be obtained. Third, properly brazed joints are pressure tight and less heating is required than for welding, so it is an economical and quick process. Besides those advantages, brazing also has some disadvantages, which are: first, reduction of joint strength compared to a welded joint due to the soft filler metals used. Second, the strength of the brazed joint is less than that of base metal but is more likely to be higher than filler metal. Third, the brazed joints can be destroyed under high surface temperatures. Brazed joints need high metal cleaning when done in an industrial setting. Also, the joint color is usually different from the base metal, creating an aesthetic disadvantage. These are the applications of brazing. Moreover, brazing can also be used in vacuum interrupters, construction, and medical equipment.
Hi everyone! In this section, we will talk about soldering. This presentation material made by Tiara Kusmadewi and revised and presented by me, Muhammad Bainur Akbar. So basically, what is soldering? In definition, soldering is a process in which two or more items are joining by fit a filler into the joint. There are some processes that have similarities with soldering, which are welding and brazing. So, what is the differences between them? The first one is welding. Welding is involved melting the workpiece, means that there are some parts of the workpiece will be melted during the welding process. However, soldering and brazing does not involve melting the workpiece. So, what is the differences between two of them? Both of them using a filler metal to join two pieces. The differences is here. Higher temperature. In brazing, the filler metal, the one that melts, need more temperature than soldering. And then we move to how it works, how the solder works. Solder is a metal alloy usually made of tin and lead, which is melted using a hot iron. The iron is heated to temperature above 600 degrees Fahrenheit, which then cools to create a strong bond. Inside the solder core is the flux, a material used to strengthen and improve its mechanical properties. And then, after the definition and how it works, we move to the types of soldering. The first type of soldering is hand soldering. Hand soldering iron is powered by electric power, which hits a rod, on tip of which the solder melts and helps to join. On cooling, the points are together as solid. As you can see in the left picture, there are preparation, heat, insert solders, pull out solder, and then pull out iron tip. So here, this is the iron tip. The red one is the iron tip, and then the yellow one is the solder. So the iron tip will become hot as the electric source, and then it will melt the iron tip, and the melted iron tip will be the one that will fix or join to the two pieces. The second type is flame soldering. Sheet metal work was traditionally done by soldering coopers directly heated by a flame, with sufficient stored heat in the mass of the soldering cooper to complete the joint. So in the previous example, the one that heated is the iron tip to melt the solder. However, in here, it's used directly using the flame or the fire. The third type is furnace soldering. This type is a semi-automatic process. Furnace soldering encompasses a group of free-flow soldering techniques in which the part to be joined and pre-placed filler metal are put in a furnace and then heated to the soldering temperature. As you can see in the left picture, there are three steps. So the first one is before going inside the furnace. So the filler is already there. When it goes to the furnace, it just will be melt. The last type that I will explain to you is the hot gas blanket soldering. This type, the heat transfer between the gas and the material to be heated is relatively low. The processes using hot gas are in most cases slow. So when in previous type the gas around is low, in this one is a bit hotter. And then we go to the purpose and application. So mostly to provide a conductive path and repairs and joining these dissimilar metals. That's the purpose. And then the application, the first one is soldering connects electrical wiring and electronic components or to PCB or printed circuit board. And then the second one is soldering is also used to join copper foil in stained glass work. The third one use the seal and repair automobile radiators. The fourth one, soldering makes quick and neat connection to electronic equipment, plumbing, and jewelry.
Hello everyone, my name is Armalia Clara Setiana and I'm going to talk about adhesive bonding. There are 5 main topics that we are going to cover: the definition, application, advantages, types of adhesive bonding, and also the joint factor. Adhesive bonding definition. The joining of the substrate known as adherent by means of the adhesive create a bond between the surfaces. Adhesive bonding results from physical and chemical interaction between the adhesive and the substrate. As we can see in the picture, that the adhesive and the adherent must be in intimate contact and have appropriate chemistry for this interaction to occur. This is controlled by the surface energy in chemistry and also for the adhesive and the adherent. There are common applications of this process such as aerospace structure, transportation, sporting goods, packaging, construction, furniture, footwear, medicine and dentistry, also consumer electronics. Structural adhesives are used in many aerospace applications, and in this field we are focused with a proper selection of the bonded system component. There are adhesive selection, surface preparation, the joint design, and also the bond processing, and the adhesive joint itself known as robust joining method. The advantages of the adhesively bonded joint are reduced stress concentration, lower assembly cost, reduced part count, lighter weight, have a greater fatigue resistance, greater durability, and also corrosion resistance. There are also common types of the adhesive material. It includes the bismuth, polyamide, epoxy, thermoplastic, acrylic, and also urethane. The design of the adhesive joint is most critical to its ability to transfer load. Therefore, in a shear loading, it is good, but in a tension and a pill loading, it is bad. We need to perform a pass in shear, not in tension, means that its appeal bond area should be sufficient to the stress to not exceed the allowable geometry. Its head, so it include stress concentration can significantly reduce, so the load carrying capability will less. There are also some consideration of the selection for the proper adhesive. It includes the shear and peel strength between the adhesive material, grip, fatigue, elongation or brittleness, viscosity, compatibility with adherent and surface preparation procedure, both life, shelf-life, and out time, temperature resistant, chemical resistant, also accurate requirements such as time, temperature, and pressure. Another consideration for the selection itself is that the adhesive with a high elongation tend to have a less temperature resistant than others, and the film adhesive tend to have a higher strength than the patch adhesive. Preparation is the most important process step. It's required to achieve the robust chemical bond, to remove the and prevent contamination, create chemical active site on the surface, and also in many aerospace metal require a requirement such as formatting layer and primer to another coating for the ultimate strength and also bond durability. Evaluation are frequently used to verify the quality of adhesive bond. Adhesive bond quality is characterized by the failure mode and mechanical measurement. There are three main failure modes, which are adhesion, cohesion, and substrate or interlaminar failure. Adhesion failure mode is unacceptable, as this means that the adhesive did not adhere to the adhering cohesion failure of the adhesive or the substrate failure, while the other are acceptable failure mode, as one can design to the mechanical properties such as the fracture toughness of the adhesive and also the substrate respectively. And at the end, we have some common test methods to evaluate the adhesive bond quality. It includes the lap sear, climbing drum pill, double cantilever beam, and also wedge crack. That's all the topic that we can cover. Thank you, and let's go to the next topic.
Now let's talk about mechanical fastener. Simply speaking, a mechanical fastener is a device that is used to mechanically join or fasten two or more objects together. The common examples of mechanical fastener are bolt, screw, nuts, etc. But out there are more than that. A mechanical fastener, in general, falls into two big categories, which are a non-permanent and permanent fastener. The differences between these two lies on its capability to be reassembled when so needed. The non-permanent characteristic means that the fastener can be assembled and disassembled repeatedly. A permanent fastener has to be destroyed in order to be removed, thus it cannot be reused. Now, based on its specific shape and functionality, we can see that there are different types of fastener which fall into that two big categories. We're going to discuss some of them, and those are bolts and screw, nuts, washer, stud, rivets, inserts, and retaining rings. Let's get into it. Bolts and screw. We define whether a fastener is a screw or bolt based on its use, not the physical shape of the fastener itself. Bolt used for the through hole and fastened with nuts. The screw is used for the tapped hole and it required no nuts. Nut. A nut is a mechanical fastener with a threaded hole. It is attached to a bolt, screw, or stud to provide a clamping force and prevent axial movement. The shaft of the bolt prevents radial movement of the part, while the head of the bolt and the nut together prevent axial movement. The most common shape is hexagonal nuts, but it also has other types of nuts such as a corn nut, speed nut, slotted hex nut, and so many others. Washer. The main purpose of washer in screw is to distribute the load of the threaded fastener. It is mainly because the thread in fastener tend to stress the material they are driven into. Washer reduces the risk of such damage by evenly distributing the fastener's load across the surface of the material. Another function of washer is as a spacer to create a padding so the screw does not go too deep, a vibration absorption, and prevent the ingress of water and liquid when dealing with waterproof seals. Some types of washer are plain, spring, and locking. Rivets. Rivets is a mechanical fastener which has a smooth cylindrical shaft as opposed to a thread, making it kind of a permanent fastener. A rivet needs to be punched to secure the end when installing. The punch allows the end of the rivet to be flatter, increasing its diameter slightly. The main use of rivets is fastening two components when only one side of it is accessible. Rivet can also serve as a cold connection when joining two parts that is impossible to use heat. Inserts. Inserts are simply act as a key to join parts. These can be in the shape of the threaded rod, unthreaded rod, key stock, or double point, etc. This type of fastener prevents uniaxial movement. Stud. Stud is a rod with varying length having thread along its length. It requires a nut to be fixed. Threaded rods combine linear and rotational movement to create a strong resistance to pressure. Stud commonly used as a pin to fasten or connect two materials together. It is also used to stabilize structure, as they can be inserted into various materials like concrete, wood, or metal to either temporarily create a steady base during construction, or they can be installed permanently. Retaining rings. Retaining rings are metal fasteners that are installed into a groove or a shaft in a housing or bore, creating a shoulder that retains its assembly. It has a simpler manufacture rather than other types of fastener, which means it will reduce the production cost. It also provides more compact and functional design rather than their traditional counterparts.